Okay, question number 3. A basketball was thrown upward. The basketball's path is given by the relation negative 0.2 times d minus 2.5 squared plus 4.5, where h is the basketball's height above the ground and d is the basketball's horizontal distance from where it was thrown, and they're both in meters. Okay, the first question here is, what was the basketball's initial height above the ground? To find out what the initial height is, you're finding out when the horizontal distance is equal to 0. It hasn't moved yet. Okay, so initial height is when horizontal distance is equal to 0. So to find out where it was initially, you want to figure out where the basketball hasn't moved horizontally yet. So we're going to plug 0 in to our d value. So solve for h when d is equal to 0. So we have our equation here, so all we're doing is plugging 0 in for d. So h is equal to negative 0.2, plug our 0 in for d, minus 2.5 squared plus 4.5. So we have negative 2.5 squared plus 4.5. Okay. So negative 2.5 squared is going to give us 6.25 plus 4.5. So here we want to calculate 6.25 times negative 0.2, which will give us negative 1.25 plus our 4.5. And that gives us a height of 3.25. So therefore, the initial height is 3.25 meters. Okay, let's move on to question B. What was the basketball's greatest height above the ground? What was the basketball's horizontal distance at this point? So that's asking us for our greatest height above the ground. This means that we're looking for the vertex. So what is the vertex? From our equation, remember, is h equals negative 0.2 d minus 2.5 squared plus 4.5. Our vertex, this is in vertex form, so we can see what our vertex is based on our equation. The vertex is the 2.5, 4.5. This is the horizontal distance. This is the vertical distance. So what was the basketball's greatest height above the ground? The height is the vertical. Therefore, the greatest height is 4.5 meters. And it says, what was the basketball's horizontal distance at that point? And that happens when it is 2.5 meters horizontally. The greatest height is 4.5 meters when the basketball is 2.5 meters horizontally. So that's just the information based on the vertex. Okay, question C. The basketball was thrown toward a net 6 meters away and 3 meters above the ground. Will the basketball go through the net? Justify your answer. So we have a basketball that was thrown toward a net that's 6 meters away, so that's your X value, and 3 meters above the ground. So we have a point of 6, 3. This is where the net is. So what we can do is we can plug our value of 6 into our equation, which is given to us. So we'll write down our equation. So if we plug our horizontal distance of 6 meters in for here, if we get a height of 3 when we plug it in, that means that the path of our basketball went directly into the net when it was 6 meters away and the net was 3 high. So we'll solve for h and find out if this happens at this point. So if we put our 6 value in, okay, so -2, 6 minus 2.5 is going to give us 3.5 squared. .5 squared is 12.25. 12.25 times -0.2 is equal to -2.45 plus our 4.5. So that gives us a height of 2.5 meters. So when the ball is 6 meters from the thrower, it is only 2.5 meters high. So therefore, when the ball is 6 meters from the thrower, or the player, it is 2.05 meters high. The basketball net is 3 meters high, therefore it does not go through the basket. The net is 3 meters high, therefore the ball does not go through the net.